Hello and welcome to this solution video of paper 32 pure math 3 of October-November 2024 series. If you like this video, please share with your friends, give it a thumbs up and subscribe to Math United. Let's get started with question number 1. They're asking us to expand this binomial up to x square, simplifying the coefficients. That's it. So, and it's worth 4 marks, which is quite a steal. So let's start. We know that 1 plus x to the power n can be expanded as 1 plus nx plus n minus 1 over 2 factorial x square plus and so on. Since we have to go up to x square, so I will write this only. But our original binomial does not have 1 here because we have 1 in the formula given to us, and this is not x. So we'll have to change this first. So what will we do? 9 minus 3x to the power half. What will I do? I will divide this whole of this binomial by 9 and I will multiply outside by 9, which will means it'll cancel out, right? But since this 9 is inside the bracket and it has a power half also, so it's 9 to the power half. So I have to multiply by 9 to the power half, which is square root 9. So square root 9 will become 3. And what do we get here? 9 divided by 9 is 1 minus 3 divided by 9 is 1 over 3x. So we have changed the binomial in the format we wanted. We wanted a 1 to lead it and 1 is leading it. This replaces x. Minus 1 over 3x replaces the x in our formula. So that's what we'll do now. So 3 remains 3. We will not look at it. We will just expand what is here. So the first term is 1 plus n. N is the power. Power is half. And x. X is not x in this case. It is minus 1 over 3x. Then we have n, which is again the power, and then half minus 1 divided by 2 factorial, and then we have x square in this formula, but we will write minus 1 over 3 x squared, and now it becomes 3 1 minus 1 over 6x, yeah, now plus half, and this one will become half minus 1 will become minus half, so it will minus 1/4 divided by 2, which will make it 8. So it is like this, 1 over 4 divided by 2. So what will that become? 1 minus 1/4 times 1 over 2, which is 1 minus 1/8. Okay, multiplied by 1 over 9 positive x square. Whenever this square is around a bracket, it squares everything, including the sign. So this becomes positive. 1 square is 1, 3 square is 9, and x square is x square. And done. We have reached x square, and now we will expand this. 3 minus 3 times 1 over 6 will be 3 and 6 cancels, minus half x. And this will be 3 will cancel out this with this 9. So it will be 3 here, so 8 times 3 minus 124. If you're not able to understand what I'm doing here, you can use your calculator and do this. I think this is the expansion. Okay. Let's go to question number 2. By sketching a suitable pair of graphs, show that the equation cot 2 theta equal to secant theta has exactly one root. Suitable, they said suitable pair of graphs. That means we can reciprocate them. Okay, though I know the graphs of cot and secant also, but what will I do? I'll write it 1 over tan 2x, which is cot 2x, equal to 1 over cos x. Let's cross multiply, it goes there, this goes here. So cos x is equal to tan 2x. And cos x graph is known to us. I will just sketch it. I hope I'll be clear enough. So since we are going to do this iterative formula later on, so we'll deal in radians. So if I say this is 2 pi, so my graph starts with 1 here and goes down, and that's the cos x graph, and the minimum of this is -1, and this is pi by 2, this is 3 pi by 2, and we have pi in between here. Alright, tan 2x. Now tan 2x graph looks like, let me change the color here. Okay, the tan graph usually is like this. So our first asymptote is at pi by 2, okay, and then it starts again, and the second asymptote is at 3 pi by 2. This is how the graph of tan looks like. But however, it is tan 2x. 2x what will do what? It will squeeze this graph horizontally. It will compress it by half. That means this pi by 2 will become pi by 4. This 3 pi by 2 will become 3 pi by 4. Okay. But they are saying as that show that the equation these which I converted to this has exactly one root between 0 and half pi. So pi by 4 is this, so double of that will be half pi. So this will be up to this point. Up to this point, this is pi. I have to draw up to this pi only. Okay. So I'll just replicate it there. So first I need to go up to pi by 2, which is here. That means this graph and this part, they finish here only. So it will be half of this will go there, then we have an asymptote here, and that's it. And we can see clearly that it is crossing at 2 points. One is before pi by 2, one is at pi by 2, but they have not included pi by 2. If you look at this one here, they have not included half pi. That means we are done. We can see that it is crossing at only one place before pi by 2. Okay. Now, suppose you are not aware how these graphs look like. You forget in exams. So you are welcome to make tables. Always make table x and y. Give some angles here. Say 0 in radians, in radians only. So 0, and then you can give 0.5, and then you can go to 1, and then you can give is pi by 2, little more than 1. Give some angles in radians, and you'll get some points like this and this, like, and then you can join them. If you do not know how the graphs look like, otherwise this is how you do it. Okay. Now, show that if a sequence of real values given by iterative formula converges to root in part A. So what they are trying to tell us, that this and this iterative formula are almost same. Why I'm saying almost, I'm not saying same, because it has become iterative formula. It was just an equation here. So in other words, this particular equation can be converted in this format. That's what they're saying. And you can see here it is tan inverse. So I will use this particular equation which I converted, and I will select this 2x, because that will give me tan inverse. So what will I do? I'll write tan. Let me start here only. So 2x equal to tan inverse cos x. Tan inverse cos x, yeah, cos x. And now I have to get rid of this because they want x to be isolated. So I will take this 2 and divide. Let's divide it here and divide here equally, so that this 2 goes. So what I'm left with, x is equal to half tan inverse cos x. and that exactly they wanted. Whenever whichever is isolated, we always write that as n plus 1. The one which is on the other side is written as xn. It is matching with whatever they wanted us to show. Okay. Next, the square root of 6 minus 8i can be expressed in Cartesian form. X plus iy, where x and y are real and exact. The square root of 6 minus 8i. So let's say square root of 6 minus 8i. Okay, and it should be x plus iy format. That's what they're saying, right? By first forming a quartic, I'm not sure why they're asking for quartic. Quadratic will do the work. How? We will just square this and square this so that we get rid of the square root in this case. So 6 minus 8i is equal to the square of this, which I will square now, x square plus I square y square plus 2i xy. Okay, this I square is minus 1, so I can write x square minus y square plus 2i xy. So now we can see that the real part here in the first part from left hand side is 6, and real part in the second side, which is right side, is x square minus y square. They are real parts, so we can equate them. It becomes x square minus y square is equal to 6, whereas this is the imaginary part and this is the imaginary part. We can equate them, so without I. So minus 8 is equal to 2xy. So we can isolate one of them here, x or y. Let's isolate x. So it becomes minus 8 over 2y. Okay, 8 and 2 can cancel, so minus 4 over y. I will use that here now. So minus 4 over y square minus y square equal to 6. So I have substituted what I got x here into this one, which becomes positive 16 over y square minus y square. Now it will become quartic, equal to 6. So if I multiply the whole equation by y square so that the denominator y square goes, so it will become just 16 minus y to the power 4 equal to 6y square. So if I rearrange it, I will bring y4 here, so it becomes positive y to the power 4. Then we have already 6y square here, and 16 comes as negative. So it becomes quartic now. So they said by forming a quartic equation, I formed it. Now I have to factorize this. For that, what will I do? I will assume that let y to the power 2 is m. So what will this become? 0 equal to m square plus 6m minus 16. And I have to solve this quadratic equation. You can use your calculator to find the roots. However, I will just split the middle term. So 0 equal to m square plus 8m minus 2m minus 16. It is m plus 8, and then we have minus 2m plus 8. So the factors becomes m minus 2 and m plus 8 equal to 0. This gives us m equal to 2. This gives us m equal to minus 8. However, m was my creation, it was not in the question, so I'll go back to what I assumed. I assumed y square equal to m. So y square is equal to 2 and y square equal to negative 8. So this becomes y equal to plus or minus square root 2. However, this is not possible because they said x and y are real and exact. Okay, so this will not give us, it will again give us a complex root, so we will ignore this. Okay, this is our y. So now we have two y's, square root plus square root 2 and minus square root 2. So if y is square root 2, what will be x? And x was this, minus 4 over y. X equal to minus 4 over square root 2 positive. Yeah, it is positive. Okay, so if I divide it, you can divide by using calculator, but I'm getting it, I will get 2 square root 2, right? Because 2 times 2 is 4, one of the square root 2 is cancelled out, minus 2 square root 2. Okay, if it is negative, y equal to negative square root 2. So x will be negative 4 over negative square root 2, which is positive 2 square root 2. Alright, so the roots therefore are x plus iy. So in this one it will be minus 2. Okay, this is negative, so I will write this later. I will write I part first. So iy minus I square root 2 minus 2 square root 2 is 1, and the second one will be which one is negative? Y is negative, so I'll write x first. 2 square root 2 minus I square root 2. These are the two roots of 6 minus 8i. Question number 4 says that solve this equation, which looks quite straightforward. Okay, so 5 to the power x is common in both the parts, so let's separate 5 to the power x from the right side also. So it will become 5 to the power x on the left side. Then we can write 5 to the power x multiplied by 5 square minus 10. So I separated x plus 2. When we have same bases, the exponents add up. So they are already adding, so I broke them into this. So 5 square is 25. So it becomes 5 to the power x equal to 25, 5 to the power x minus 10. And now we can assume let 5 to the power x equal to some alphabet t. What does this become? T equal to 25 t minus 10. And let's leave it 0 here, t comes here, 25t, or let's bring it to the other side, that will be even easier. So t minus 25t is equal to minus 10. So minus 24 t is equal to minus 10. T is minus 10 over minus 24. Both cancel out, and we can convert it to a smaller fraction, which is 5 over 12. Okay, but t was my creation, so I will put it back. 5 to the power x is t equal to 5 over 12. This is what we have to simplify now. And since this is an exponential form, it can be converted to logarithmic form, which is log base 5 over 12 equal to x. This is what I have converted. Just put this in a calculator and you'll get your answer. And they said answer, not answer, so only one answer possible. Let me do it myself, which comes out to be minus 0.543959, to so many digits after this, but we will round it off to this through 3 decimal places. So minus 0.544 is the answer for this question. Question number 5. The complex number u is given by this expression. Okay, find the exact value of argument of u. We have to find the argument of this one. Okay, let's convert these to polar form, exponential forms first, and then we can talk about u. So if I put 1 in front of this and 1 in front of this, doesn't it become modulus and argument form? So the first one, 1 cos 1 over 7 pi plus I sine 1 over 7 pi, right, to the power 4. So if I put power 4, 1 to the power 4 here, that will not make any difference, which means I can write this as 1 cos 1 over 7 pi plus I sine 1 over 7 pi to the power 4, yeah, outside. And this can be written in exponential form as 1, because 1 is the modulus. If I write it or don't write it, doesn't make any difference. And this will be I 1 over 7 pi. Yeah, this is the exponential form, and since it is power 4, I will write power 4 also. So u becomes e to the power I 1 over 7 pi to the power 4 divided by, let's focus on the denominator now. So the denominator can be written as 1 cos minus 1 over 7 pi plus I sine minus 1 over 7 pi, like this. And why did I do that? Because in fourth quadrant, in this quadrant, if I talk about, if I this argument is minus 1 over 7, it will be this way, right? And in this quadrant, cos is positive, right? So that's why a positive angle becomes negative, still the cos will give us the same value. Similarly, here in the fourth quadrant, sign is negative. So if I bring this negative sign, which was, where was it? Yeah, it was this negative sign. This negative sign, if I bring it with the angle, then I can put plus here, because my exponential form can be converted from plus sign only, not with minus. So this becomes e to the power I, and 1 I'm ignoring again because 1 doesn't make any difference, I 1 over, rather negative, it will be negative 1 over 7 pi, right? So I will write that here, e to the power negative I 1 over 7 pi, like this. Now, since both of them have e as base and they are dividing, we can write u is equal to e to the power I 1 over 7 pi. Rather, can I multiply this 4 with 1? So it will become 4 over 7 pi. 4 over 7 pi. So this 4 is also gone. It multiplies with the exponent here. Okay. Minus, because it's dividing, minus I 1 over 7 pi. Now, it is 4 over 7, it is plus, because there are two negatives. So it will become plus 1 over 7 pi. So our answer will be u equal to ei 5 over 7 pi. Right? This is our polar form or exponential form for u. And now we can find the exact value of argument. So argument of u is clearly visible here, which is 5 over 7 pi. That's it. Now, the complex number u and its conjugate are plotted on an Argand diagram. Okay. Describe the single geometric transformation. So, whenever there is there is a conjugate of a complex number, only the imaginary part changes. So, suppose this is 5 over 7, positive 5 over 7, right? It's positive 5 over 7. So, it will be somewhere here. If conjugate is written, conjugate is that only the imaginary part changes its sign, real remains what it is. So whatever real is this one, imaginary is this one. This will be changing to its negative part here. So our final complex number will be somewhere here, and this is our 5 over 7 pi. That's the argument of u. The argument of u star, this will be u star conjugate, will be negative 5 over 7 pi. So they're saying describe the single geometric transformation. The single geometric transformation will be reflection over real axis. This is single geometric transformation, and state the exact value of conjugate, argument of conjugate. So argument of conjugate of u will be negative 5 over 7 pi. Okay, question number 6 says the variable x and y satisfy this equation ay equal to b to the power x, where a and b are constants. The graph of natural log y against x is a straight line like this, passing through these 2 points as shown in the diagram. Find the value of a and b. So what will we do? We'll first find the equation of this line, which is equation of a line is y equal to mx plus c, right? So we'll start it here, but we will write capital Y because our y is not normal y, it is natural log of y. So we'll write capital Y is equal to mx plus c. Though our independent variable x is small x, but I will still write it to remind me that this is not the normal equation. Normal equation is this one, which we have to convert it later on. So c, we don't know c yet, but first we can find m, the gradient. M will be y2 minus y1 over x2 minus x1 for a straight line. This is a straight line, so we'll do that. 8.27 is y2 for me, this one, minus 2.24 over 3.40 minus 0.50, which comes out to be how much? 6.03, yeah, divided by 3.4 minus 0.4 will be 2.9. Okay, so let me see if I get something out of 6.03 divided by 2.9. 6.03 divided by 2.9, it gives me 2.079. Let me say, okay, 079. It's for the time being I will do that. So 2.079 is the gradient. Okay, now I need to find c, and I will substitute one of these 2 points to get c. Let me substitute the easier one, which is this 0.50 and 2.24. So in this equation I'll put that, so which will be 2.24 equal to m, x is 0.50 plus c. Sorry, m is known to me. I should write that m, which I know now. 2.079. Alright, so c becomes 2.24 minus 2.079 times 0.5, which is 1.2005. So I'll write just 1.2. So I got c also. So our equation, this equation which was here, becomes y is equal to 2.079 control, okay, 079 x plus 1.2. Now I have to convert this into this format. Okay, and how can I do that? I will write the actual ones down. It will be natural log y in place of y now. So natural log of y is equal to 2.079 x, small x now, plus 1.2. Now if I remove natural log from this side, it will be e to the power the whole of it. So e to the power 2.079x plus 1.2. Now since this is adding, that means I can separate this 1.2 from this by this way. E to the power 2.079x multiplied by e to the power 1.2. So let's evaluate this one. Y is equal to e to the power 2.079 x, and this becomes 3.32. Now if we look at our format, we want the a should have a coefficient. So this 3.32 we can bring, because it doesn't have any variable with it, so we can bring it here. It will become 1 over 3.32y. So we got a coefficient for y. Now we want just a number b to the power x. X is already here. We can evaluate e to the power 2.079 and give it a power x. Ultimately 2.079 and x will multiply also. But we don't want, we want this to be one number. And that's what I'm going to do now. I will evaluate this. So I will write e to the power in my calculator, e to the power 2.079, which gives me 7.996, which is 8. So 1 over 3.32 will be 0.3. One significant figure they are asking, right? One significant figure. So 0.3y is equal to, this came out to be 8 to the power x. And now we can write that a is 0.3, b is 8. We wanted a and b, one significant figure, done. Question number 7 talks about trigonometric equation, which is a cubic trigonometric equation, and we need to convert it to a quadratic trigonometric equation in terms of tan. So what we can do, that we can write tan cube as tan square times tan, and 2 tan 2 theta is also converted to tan. That's what we can do here. So we can get this particular format. So I'm doing tan x times tan square x, this one, okay, plus 2, and tan 2x, its expansion will be 2 tan x divided by 1 minus tan square x. Then we have minus tan x equal to 0. Okay, so I got tan square here, I got tan and tan both here. So now I will take tan common from all three of them. See, this is tan, and this is tan. Let's get rid of tan. So what is left in this one? Tan square only, plus 4 tan, just 4 other, just 4, because tan is already taken common. 4 over 1 minus tan square x. Then here tan x is already out, so minus 1 equal to 0. Now our job is to get it to quartic, and this can't be converted to quartic. So we can say that tan x is equal to 0 is one answer from this equation, and tan square x plus 4 over 1 minus tan square x minus 1 equal to 0 is one answer for this. However, they have clearly said tan x is not equal to 0. That means this answer will be ignored. This is not valid. We will concentrate on this one. Now here the problem is that we have 1 minus tan square x as denominator. So what do? We can multiply the whole equation by 1 minus tan square x, so that when it is multiplied with this particular term, this 1 minus tan square x and 1 minus tan square x cancel out. Okay, so that's the purpose of multiplying by this. So first this will multiply with tan square x, this one. So tan square x times 1 will be tan square x. Tan square times minus tan square x will be minus tan to the power 4x, and we have got a quadratic part. Yeah. Now, plus 4 over 1 minus tan square x. 1 minus tan square, they will cancel out, so we'll be just left with 4. And that was the purpose of multiplying with this, so that denominator is gone. Minus 1 times 1 will be 1. Minus 1 times minus tan square x will be plus tan square x equal to 0. And if I rearrange them, I'll write the quadratic part first. Okay, then I will write this tan square and tan square. There are two tan square x, and then we have 4 minus 1, 3 equal to 0. The format is correct, but the signs are different. So if the signs are like this, we can again multiply by minus 1. So that's the rule. We can multiply the whole equation by same element. Here we multiply by 1 minus tan square x. Here I am multiplying by minus 1. I wasn't aware that tan to the power 4x will become negative, and others will have different sign. Now I want to change sign, so I'll multiply by minus 1. So finally we get tan to the power 4x minus, because this plus and this minus will make it minus, 2 tan square x minus 3 equal to 0, and this is what they asked us to show. Alright. Hence, solve the equation tan cube 2 theta. Okay, is it matching with the previous one? Yes. Let's see, tan cube 2 tan and minus tan x. Only difference between that one and this is that here we have x, there we have 2 theta. That's the difference, and that's what we'll do. So I will substitute this x by 2 theta, and it will be the same thing as this. So let's do it. My new equation for part B becomes tan to the power 4x, so it will become tan to the power 4 2 theta minus 2 tan square 2 theta minus 3 is equal to 0. Okay, and I have to solve this one. So let's do one assumption here. Let tan to the power tan square 2 theta equal to say m, an alphabet m. And so this becomes m square, right? Because if I square this, it will become 10 to the power 4 2 theta. So it will become m square on the right side. So this is equal to m square minus 2m minus 3 equal to 0. This is the new formation of this equation, trigonometric equation. And I can split the middle terms to get this answer. So I'm splitting minus 2m to minus 3 and m, because the factors of minus 3 are minus 3 and 1. That's why I did this equal to 0. So if I take m common here, I'll be left with m minus 3 plus 1, m minus 3 equal to 0. Okay, and now we can easily say m plus 1 m minus 3 equal to 0. This gives us one answer, which is m plus 1 equal to 0. This gives m minus 3 equal to 0. However, m was my creation, so I have to go back to tan square 2 theta. So it will become tan square 2 theta equal to minus 1, and tan square 2 theta equal to 3. Since it's a square and the square cannot be minus 1, so this answer is rejected. It's an invalid answer, so we'll focus on the other one. We square root both sides, so we get what? Tan 2 theta equal to plus minus square root 3. I square root both sides. Okay, so since it's plus and minus both, and our angle is 2 theta. So if we draw the quadrants, let me draw quadrants here. Positive, tan will be positive in these two quadrants and negative in these two quadrants. So the answers will be in all four quadrants for 2 pi, the whole 360 degrees angle plane, but it is up to pi only. Our answer has to be up to pi. So we will go to 2 pi because of this 2 theta we have to half the angle. So we'll see all the answers. The first one, so let's say first answer will be 2 theta equal to tan inverse square root 3 positive. So it is positive in two quadrants, we'll get two answers out of them. So first answer will be from 0 degrees here till the first line. This is the first answer, which will be 2 theta equal to tan inverse square root 3. In first one, this will be how much? Tan square root 3 will be pi by 3. Okay, it will be pi by 3. So the first answer should be theta equal to pi by 6, because this 2 will go and cross multiply by 3, pi by 6. This is our first answer. Okay. Second, 2 theta equal to, in this quadrant, this will also be pi by 3, because here it is positive, right? We are talking about when square root 3 is positive. So it will be how much? Pi up to here. So from 0 we'll reach up to here, which is pi plus pi by 3. So it will 4 pi by 3. 2 theta equal to 4 pi by 3. Cross multiply again. Theta comes out to be 4 pi by 6, which is again cancel 3 and 2. 2 over 3 pi. This is our second answer. Two answer we got for positive. Now our second option is 2 theta equal to tan inverse minus square root 3, and for that we'll take the negative quadrant, these two quadrants. So our first angle in that will be up to this line, but the angle is pi by 3 again, because negative sign is taken care of the quadrant, but the angle remains pi by 3 here. So it will pi minus pi by 3. That will be your this answer, the third one, which is 2 theta equal to pi minus pi by 3, which is 2 pi by 3. 2 theta equal to 2 pi by 3. Cross multiply. 2 will multiply, yes. So it will become 2 pi by 6. Or cancel again, which is pi by 3. 1 over 3 pi is your third answer. Remaining fourth answer will be the angle which is up to here. This angle is also pi by 3. It is that angle pi by 3 is always with the horizontal line, or never with vertical line, always with horizontal line. So it is 2 pi minus pi by 3. So the next answer will be 2 theta equal to 2 pi minus pi by 3. So 2 theta equal to 6 minus 1, 5 pi by 3, and theta by cross multiplication will be 5 pi by 6. This is your fourth answer. So 1, 2, 3 and 4. These are the four answers for this question number 7. Question number 8 gives us parametric equations of a curve, which is x is this and y is this, for t between 0 and 1/4 of pi. Show that dy over dx is this. So first I will find dy over dt. That means I will differentiate this one. So the differentiation of cos t will be minus sine 2t, and then we have to differentiate the angle as well as a chain rule. So multiplied by differentiation of 2t, which is just 2. So answer is minus 2 sine 2t. Okay, now we'll find dx over dt. That means we'll differentiate x with respect to t. First, this 2 will come in front for differentiation. 2 tan 2t, because the exponent goes down by 1, right? That's the normal one. Then multiplied by chain rule, we will differentiate tan 2t, the base of square, which is tan 2t. So the differentiation of tan 2t is secant square 2t, and then we differentiate the angle again. So differentiate 2t, here we get 2. So the final answer will be 4 tan 2t secant square 2t. Okay, but it does not match to our requirement, right? But we have just dx over dt and dy over dt right now, so we have to use this chain rule again. Dy over dx, that's what our requirement is, should be equal to dy over dt multiplied by dt over dx. Yeah, that's how dt and dt will get cancelled out, and we will be left with dy over dx. So dy over dt first, we already have dy over dt minus 2 sine 2t. So let me write here, which will be equal to minus 2 sine 2t multiplied by dt over dx. That means the reciprocal of what we got here. So reciprocal of that will be 1 over 4 tan 2t secant square 2t. Again, it does not match with what we want, but we already have minus, correct? We also have 1 over 2, which is 1 over 2. Only thing remaining is now cos cube t is needed. So we'll convert this tan and secant into cos. So what will be there? Y equal to minus 1 over 2 is already with us. Sin 2t remains sin 2t. Divide by. Okay. First of all, tan 2t will be converted into sine and cos. So it will be sine over cos is tan, right? So sine will, because it's a denominator, it will be sine 2t here and cos 2t here. That becomes a denominator of sine 2t, tan 2t rather. And secant square 2t will be 1 over cos. So 1 will be staying here and cos will be going up. Cos square 2t. And now we can cancel sine 2t with sine 2t. So it is 1 over 2. Cos 2t times cos square 2t will be cos cube 2t. And exactly this we wanted to show, right? Alright, B part. Hence find the equation of the normal to the curve at the point where t is equal to 1 over 8 pi. So curve is this parametric equation is the curve. So let me write the curve equation here. X equal to tan square 2t and y is equal to cos 2t. Now I want equation of a normal. Suppose this is the curve. Okay, I don't know where is the curve, and the t equal to 1/8 of pi is this one. Okay, let me redraw this. Okay, at this point we want the equation of normal. It's equation we want. Okay, normal is a line. So what is the equation of a line? Y minus y1 equal to m x minus x1. Y and x are integral parts, general x's and y's on a curve, so they will remain what they are. Y minus something equal to something x minus. We should be very, very clear about this. We should not touch these. Only thing is that I want x1 means the specific point, this point. What is the x coordinate of this? They are x1 and y1, right? But they have already given that the t is 1 over 8 pi. So we can easily use these two equations to get x and y. at this particular point where t is 1 over 8 pi. So what is x1? Tan square 2t. 2 times t. t is 1 over 8 pi. So 2 and 8 cancel. So basically 1 over 4 pi. So tan 1 over 4 pi is 1. So it becomes 1 square, which is 1. Let's talk about y1, which is cos 2t. Cos 2t. Again this cancels. So cos 1 over 4 pi, which is square root 2 over 2. We got both. So x1 is 1 and this is square root 2 over 2. Alright, so square root 2 over 2 and 1. Now left what? M. For m, we should know that dy over dx we got in previous part is same as m of tangent. Right? I means gradient of tangent, but we want gradient of normal here. This m is of normal. So first we will have to find tangent, then we can find normal's gradient. So dy over dx we got at minus 1 over 2 cos cube 2t, which is minus 1 over 2 cos cube 2t. This is what we got as dy over dx. Okay, so we'll substitute 1 over 8 pi here also. So m tangent equal to minus 1 over 2 cos cube 2 times 1 over 8 pi. So that comes out to be how much? Minus half cos cube, this again 4, so square root 2 over 2 cube, right? That is the value of cos 1 over 4 pi, and we have to cube it because there is a cube here, which comes out to be minus 1 over 2, 2 square root 2 over 2 cube is 8. So 2 and 2 cancel. Square root 2 over 8. This is the gradient of, minus also, of tangent. But the gradient of normal, gradient of normal will be the negative reciprocal of this, which is minus. Why? There's one minus here and there's negative reciprocal of tangent's gradient is written. So 8 over square root 2. That is the gradient of the normal. So let's not think about the rationalizing denominator yet, because maybe that there it will be okay. So it will be 8 over, or yeah, we can solve this, we can simplify this. 8 is 4 times 2, so it will become 4 square root 2. If we put this in a calculator, it will give you 4 square root 2. Yes. Okay, so that becomes 4 square root 2. And now, did they ask that we have to write? Yeah, we have to write this format, y equal to mx plus c. So y has to be here. Let's bring this to the other side. So y is equal to 4 square root 2x minus 4 square root 2, and this also goes to the left side, becomes square root 2 over 2. So we got, because this is the format we want, y equal to mx plus c. So y equal to 4 square root 2 x, and square root 2 is common in these two. Let's take that common. Yes, square root 2 common. We'll be left with 4 minus half. Yeah, 4 is this, and because square root 2 was taken common, half is left in this one. So it will be 7 over 2. So final answer should be y equal to 4 square root 2 x minus 7 square root 2 over 2. This should be the equation of the normal. I hope I have not made any casual mistake here. If I have done so, please Let me know this in comments. And there is marking scheme is not out yet. I'm answering this without a marking scheme. It says with respect to origin, the points A, B, C have position vectors these three. Okay. So let's say A is here. I'm not sure if this is correct, but let's say A, B, C. I will change the places if it does not match. And this is origin. So this is OA, this is OB, this is OC. All right. And these are their vectors, position vectors. The point is such that ABCD is a trapezium. All right. So AB and CD, what are the parallel lines? With DC equal to 3AB. That means DC and AB are parallel. Because one vector is a scalar multiple of the other, means they are parallel. So AB is this, CD has to be, CD is longer? Yes. So CD has to be this, parallel, these two will be parallel. This line and this line are parallel. So suppose this is D. So it becomes trapezium. A, B, C and D. Okay. Find the position vector of D. Alright. So first what we will do, we'll find this vector AB. So vector AB will be the position vector of B minus position vector of A. Always head minus tail. Head is at B. So head minus tail, position vector of head minus position vector of tail. So 0, 4, 1 minus OA, 2, 1 minus 3. Okay. Which comes out to be 0 minus 2 will be minus 2. 4 minus 1 will be 3. 1 minus minus 3 is 4. 2, 3 minus 4 is AB. Now, DC, that means head is at C, tail is at D. Okay, so DC will be OC minus OD. And OD is what they are asking. Yeah, find the position vector of D, which is OD. This is what they are asking. That means first we will say DC. So DC 3 times this. 3 times minus 2, 3, 4. 3 times AB is DC equal to OC is minus 3, 2, 2 minus OD. Let's call them P, Q, R. Okay. So now we can easily make equations out of them. So first equation for x component, 3 times minus 2, minus 6 equals to minus 3 minus P. So let me bring P to the left side. P becomes positive and it becomes minus 3 plus 6, which is 3. Q. The equation will be 3 times 3, 9 equal to 2 minus Q. Okay, Q goes to the left side. Q is 2 minus 9, which is negative 7. Alright, and R. So 3 times 4 is 12, third one, equal to 2 minus, is it minus 3, 2, 2, minus 3, it was minus 3 minus 2, this was minus 2, minus 3 minus 2, 0, 4, 1. I hope I have not made any other mistake. Alright, so this would change, 9 minus 2 minus Q. So this will be minus 2 minus 9, which becomes minus 11. Alright, so this is 2. Okay, so 12 equal to 2 minus R. So R goes to the left side, 2 plus minus 12, which is minus 10. So the position vector OD of D, OD is equal to P was 3, Q was 11, and this was minus 11, and this is minus 10. Done. We found the position vector of D. Okay. The diagonals of the trapezium intersect at point P. Find the position vector of P now. Okay. So let's try to redraw that trapezium. Since the position vector of all four are known to us, we'll just write coordinates out of them now. So OA was 2, 1, minus 3. 2, 1, minus 3. 0, 4, 1 is B. 0, 4, 1. Then we have OC minus 3, minus 2, 2. And D we found out was this one, 3 minus 11, 10. 3 minus 11, 10, minus 10. Okay, this is D. Now we want to draw their trapezium's diagonals, which is this and this. Okay. So let's call these coordinates where these two lines are intersecting as L, M, N. I'm avoiding A, B, C and other general ones because sometimes they are something else. So this point L, M, N is lying on both the vectors. Okay. So that means this L, M, N will satisfy the equations of these two lines. So let's call this line as line 1, this one as line 2. So the vector equation of line 1. Okay, will be any one point, let's say 3, let's not use this one, we'll use this one, 0, 4, 1. It is easy, smaller numbers, right? So it will be 0, 4, 1 plus let's say alpha and the vector. What is the vector? 3 minus 0 is 3. That's the vector with this one. Minus 11, minus 4, minus 15, minus 10, minus 1, minus 11. What is the equation of line 2? Line 2 is this one where I'll take one of the points, let's say 2, 1, minus 3. 2, 1, minus 3 plus beta. And the vector 2 minus minus 3 will be 5. 1 minus minus 2 will be 3. And minus 3 minus 2 will be minus 5. So these are the equations. Now since this point L, M, N lies on both the equations, this L, M, N will satisfy both of them. So L, M, N. Suppose this is the position vector of the intersecting point, let's call it E. Okay, will be same as 0 plus 3 alpha, 4 plus 4 minus 15 alpha, and 1 plus 1 minus 11 alpha. And also will be same as 2 plus 5 beta, 1 plus 3 beta. I hope I have not made any mistake in signs. Minus 3, the marking scheme is not out yet. So I am solely on my own. Minus 3 minus 5 beta. Okay. Now we know that the point is common in both. That means 3 alpha is same as 2 plus 5 alpha. 5 beta rather. 3 alpha is same as 2 plus 5 beta. Okay. 4 minus 15 alpha. 4 minus 15 alpha. 4 minus 15 alpha is same as 1 plus 3 beta. So let's use substitution method. No, let's use elimination method. So I'll take this 4 to the other side here. This equation becomes minus 15 alpha, this one. 1 minus 4 will be minus 3 and plus 3 beta. And now I will multiply this equation by 5, this one, by 5 to eliminate. How? This 3 will become 15 by multiplying by 5, so it will become positive 15 alpha, and it will be easy to cancel out with this 15 alpha. Alright, 2 times 5 is 10, and 5 times 5 is 25 beta. Okay, so cancel out. So it becomes 7, 0 equal to 7 plus 28 beta. So beta is minus 7 over 28, which is minus 1/4. Since we have gotten beta here, there's no need to find alpha, but let's still find it, because it is useless to find, because we want this position vector of P, right? I called it E, should be P, okay? We should be finding lmn with the help of minus 1 over 4, but still, to confirm that our answer is right, let's see. Let me use this equation to get alpha. So 3 alpha is equal to 2 plus 5 times minus 1/4 beta. So it becomes 8 minus 5. 8 minus 5 is 3. So 3 alpha is equal to 3 over 4. And 3 and 3 cancel. Alpha is equal to 1 over 4. So now if I substitute minus 1 over 4 in this, or 1 over 4 in this, I should get exactly same position vector. And let me do both, because marking scheme is not out, so I'm confirming that my answers are right. So from here it will be 3 alpha. 3 alpha gives us minus 3 over 4. No, alpha came out to be positive, right? So it will be 3 over 4 positive. Okay, now the y component will be 4 minus 15 times 1 over 4. So 16 minus 15, 1 over 4. Okay, now see, 1 minus 11 over 4. 1, 4, so it becomes minus 7 over 4. Okay, this is because of alpha. Let's say because of beta, we should get exactly same number. 2 plus 5 times minus 1 over 4. 2 plus 5 times minus 1 over 4, which is 8 minus 5, 3 over 4. Yes, same. Then second one is 1 plus 3. 1 plus 3 times negative 1 over 4. So 4 minus 3, which will be 1 over 4. Yeah, same. Third one is minus 3 minus 5 times minus 1 over 4. So minus 12 plus 5. Minus 12 plus 5 will be minus 7 over 4. See, we got the same. So this is the position vector of P, OP. This is the answer of the position vector. Now, using scalar product, calculate angle ABC. ABC. So this is the angle which we have to find. That means the angle should be from tail to tail. So I should know BA, not AB. BA should be my first vector. So BA, let me write opposite of AB. This was minus 2, 3, 4. Minus 2, 3, 4. Minus 2, 3, 4. Since I want BA, it will be opposite of minus 2, 3, 4. It will be 2, minus 3, minus 4. In place of AB, I have written BA because I want tail to tail angle. We can't have head to tail angle. And now I will have the vector BC, right? That means OC minus OB. We don't have BC, so we will find it somewhere here. BC is equal to OC minus OB. So let me find OC and OB. OC. Minus 3 minus 2, 2. Minus 3 minus 2, 2. Minus OB. OB will be how much? 0, 4, 1. 0, 4, 1. So BC comes out to be minus 3 minus 0, minus 3. Minus 2 minus 4, minus 6. 2 minus 1, 1. So we have to find the angle between this and this vector, and the formula for that is that A dot B is modulus of A modulus of B cos theta, and theta is cos inverse A dot B over A B magnitude. That's it. All right. So A for us is BA. All right. So let's find the dot product first of these two vectors. So 2 minus 3 minus 4 dot minus 3 minus 6 1. Okay. So dot product will be 2 times minus 3 minus 6. Minus 3 times minus 6 is plus 18. Minus 4 times 1 is minus 4, which is 8. Yeah, minus 10 plus 18, 8. So we got here cos inverse eight over. Now I have to find magnitude of A, which is this vector. So magnitude of BA will be 2 square plus minus 3 square plus minus 4 square. Always put them in bracket. So 9 plus 16, 25 plus 4, 29. Okay, the magnitude of this one, BC, minus 3 square plus minus 6 square plus 1 square. 9 plus 36, 45 plus 1, 46, square root 46. Just put this in a calculator and you'll get the answer. For me, it comes out to be 77.34762, so I will write 77.3 degrees. That's the angle. Question number 10. A balloon in the shape of a sphere, okay, has a volume V and radius R. So volume of a sphere is V equal to 4 over 3 pi R cube. So this is R. Air is pumped into the balloon at a rate of 40 pi, starting when T is 0 and R is 0. Okay, R cannot be 0, but yeah, for practical reasons it is 0, they have said. So it is being pumped in. That means dV over dt, the volume of the air inside the sphere is increasing at a rate of 440 pi. Okay, that's dV over dt. At the same time, air begins to flow out of the balloon at a rate of 0.8 pi r. That means it is reducing also by 0.8 pi r. Okay. The balloon remains a sphere all times. Okay, that's a good information. Show that R and T satisfy the differential equation, this one. So we have to arrive at this one. Okay, so we already have this equation with us. Volume is equal to 4 by 3 pi r cube, and it remains a sphere. That means whatever change is happening with respect to radius, that will be the differentiation of this. So 4 over 3 pi r cube will be 4 over 3, pi remains pi. So 4 over 3 is a constant, pi is a constant, we don't touch it, just r cube will be differentiated, 3r square. 3 and 3 cancel here. So this is dV over dr. So we can write here dv over dr equal to 4 pi r square. Okay, now if I somehow divide this particular expression by d over by dt and dt, and the dr over dt, that's what they want. So dr over dt, we can take this as the subject now. So I'll take this here and 4 pi r will come down. So dr over dt becomes 4 dv over dt divided by 4 pi r square. Okay, now dv over dt, we just found out it is 45 minus 0.8 pi r, so I will substitute that. 40 pi minus 0.8 pi r divided by 4 pi r square. First thing first, we cannot cancel this pi and pi, but we can cancel if both of them have pi, because it will be factored out and it can cancel with this pi. So all pi's are gone. Now 4 can divide. Okay, I can separate this also. Should I separate? No, they want this format, so I should not separate. So what will I do now? I divide r square has to be here and it has to be 5. So let's multiply this by 4 pi. Let's divide this by, how can I multiply this 4 so it becomes 5? So let's multiply by 1.25. Okay, so what will I do? To make this 4r square as 5r square, I'll multiply the denominator by 1.25. But I can't do that. Only to one side I have to multiply numerator also by 1.25 to balance it. So now the denominator comes out to be 5r square. Okay, 4 times 1.25 is 5, r square is r square. Now 1.25 times 40 will be 50 minus 1.25 times 0.8 will be r, 1 r basically, 0.8 multiplied by 1.25 will be 1 r is this, and exactly what they wanted us to show. This is dr over dt. Okay, find the quotient on remainder of 5r square when it is divided by 50 minus r. So I will do the long division in this case. 50 minus r divides 5r square. So first thing, this is minus r, which is the higher order variable. So I will see what can I multiply this with. It will be 5 minus 5r I multiply, so it becomes positive 5r square. And 50 also multiplies with minus 5r gives me minus 250r. I will subtract them now. This will become positive, so this cancels out and we are left with 250r positive. Now to make this minus r as 250r, I'll multiply with the minus 250. So it becomes 250r, and 50 multiplied by 250 will give you minus 12500. I subtract this, I make this positive, cancel out, remainder is 12500. So they said find the quotient, so this one is quotient, and this one is remainder. All right, solve the difference equation in part A, which is this one, obtaining expression t in terms of r. 50 minus r, 5r square. Okay, I'll start here. 50 minus r over 5r square was dr over dt. To solve differential equations, r should be with r and t should be with t. T should be with t, and there is no t here. That means t will cross multiply here and these two will cross multiply to the left side. So what will this become? 5r square over 50 minus r dr. This dr remains where it is. They change the place. Equal to, and dt goes and cross multiplies to the other side, just dt. But 5r square over divided by 50 minus r, we already got this quotient and remainder. So we can write this as, let me write here, it will become minus 5r minus 250 plus, it was plus, right, 12500 divided by, what was the divisor? 50 minus r. 50 minus r, this is our left side now. dr is equal to dt. And now we will integrate both sides to get t in terms of r, and t, this will give me t, so t is already there. This minus 5r will become minus 5r square over 2. 250 will become minus 250r, and this is a linear denominator. So if I differentiate that, it will become what? 12500 is a constant. I will not touch it, and this will become what? 50 minus r. It will become natural log 50 minus r divided by minus 1. Why? Because we divide by the differentiation of whatever we are applying natural log to, and then plus c. So let me erase this thing and put this completely after that. So plus c, and this will be equal to t, right? And we got it here. Now we can write the proper sentence here, if this is possible to write proper equation. T is equal to minus, is a positive something positive, this is not negative, this is negative, that is negative. Okay, everything is negative. Minus 2.5 r square minus 250 r. This minus will make it minus 12500 natural log 50 minus r plus c. However, they have already given us, to get the value of c, they have already given us the starting point, if you remember. When t is 0, r is 0. So that's what we'll do here to get the value of c. When t is 0, r is 0. So this becomes 0. Those whole thing becomes 0. This is also having r 0. This will give us something, I think, 12500 natural log 50 minus 0, which is 50 plus c. Okay, and let me take this one to the left side. So 12500 natural log 50 equal to c, and this value of c will plug in the main equation. So it becomes t equal to minus 2.5 r square minus 250 r minus 12500 natural log 50 minus r, and now we got c equal to 12500 natural log 50. I can evaluate this as a decimal also, but I will avoid that. They have not asked us to enter. This is the expression I'm getting. Okay, t in terms of r. Now the final part says find the value of t when radius of balloon is 12. So I'll just multiply this r by 12, not multiply, substitute by 12. So minus 2.5 12 square minus 250 12 minus 12500 natural log 50 minus 12 will be 38 minus 12500 natural log 50, and I'll just put this in my calculator and I will get the answer. This had to be positive, and answer I'm getting is t equal to 70.460, so I can say 70.5 seconds. That is the answer. Says find the derivative of fx and hence find the exact coordinates of the stationary point. There is only one stationary point of the curve with equation y equal to fx. Okay, so to find the derivative we will use quotient rule. For quotient rule we square the denominator first, so e to the power 2x minus 3 e to the power x plus 2, square it. Then we write exactly same what we wrote, the denominator down there without square, we will write it and multiply it with the derivative of the numerator. Derivative of numerator will be 2 e to the power 2x multiplied by 2, the derivative of the exponent, so it becomes 4 e to the power 2x. Then subtract. This time the numerator will remain 2 e to the power 2x, whatever it is. Here denominator remained same and numerator was differentiated. Now numerator will remain same and denominator will be differentiated. What is the differentiation of e to the power 2x? 2 e to the power 2x. Differentiation of minus 3 to the power ex will be exactly same, no change. And differentiation of 2 will be 0. We will not write it. Okay. Okay, so let's focus only on the numerator. Denominator we will not even touch. So denominator remains what it is, e to the power 2x minus 3 e to the power x plus 2 square. And I will open up these two brackets. So 4 e to the power 2x multiplied by e to the power 2x becomes 4 e to the power 4x. 4 e to the power 2x multiplied by minus 3 becomes minus 12 e to the power 3x. 4 times 2, 8 e to the power 2x. Now here minus 2, then this becomes minus 4 e to the power 4x. Minus 2 times minus 3 is plus 6 e to the power 3x. Okay. So 4 to the power 4x and 4 to the power 4x, they are same and opposite sign, cancel out. Minus 12 plus 6, it is minus 6 e to the power 3x, and then 8 e to the power 2x divided by e to the power 2x minus 3 e to the power x plus 2 square. This is the derivative of fx. Now they said find the exact coordinate of the stationary point. For stationary point, f prime x has to be equal to 0. The derivative has to be equal to 0. Why? Because if it is a maximum, its tangent to this is a horizontal line, minimum tangent is horizontal line, both of them have gradient 0, and f prime x is nothing but gradient. It is equal to 0, we do it. Now such a complicated denominator will become 0 when it cross multiply with 0 becomes 0. So we are left with just minus 6 e to the power 3x plus 8 e to the power 2x equal to 0. Let's take e to the power 2x, rather 2 e to the power 2x common from this. So we are left with minus 3 e to the power x, and here we will be left with 4e, just 4, not plus, it will minus. Minus taken, no, we took positive common here, right? So let's take this one common. So it will be positive here and 4 here equal to 0. So this gives us two possible answers. One is this, minus 2 e to power 2x could be 0, or 3 e to power x minus 4 equal to 0. E is a constant. No matter what power we give to it, it will never become 0. So this answer is rejected. And that's why they say stationary point. That means only one answer should be there, which is this. 3 e to power x is equal to 4 e to power x is equal to 4 over 3, right? And x will be natural log 4 over 3. Okay, that's the x coordinate. We want to find y coordinate. And for y coordinate, we will place this particular value natural log 4 over 3 into the main equation, which was this. So 2 e to the power 2 times natural log 4 over 3, okay, divided by e to the power 2x 2 natural log 4 over 3 minus 3 e to power natural log 2 natural log. I'm sorry if I'm making a mistake. 2x, x is natural log only, right? So not 2. Okay. All right, and plus 2. First thing first, we should neutralize natural log and e, which are inverse of each other. So this will become minus 3 times 4 over 3. Similar things should happen here. So what can I do here in this case? This 2, I can make a square of this. So this 2 is gone. And once it has gone there, then now e and natural log will also neutralize. So it will become 2 times 4 equals 16 over 9. Okay. Similarly here, this 2 goes to this side and natural log and e neutralize. So it becomes 16 over 9, just 16 over 9 plus 2. All right. So what do we get here? 32 over 9. 32 over 9 divided by, what will that be? 3 and 3 cancel. So 16, and this is minus 4, then that means minus 4 and plus 2 is minus 2. I'm doing it mentally, please do it yourself. So 16 minus 18 will be minus 2 over 9. Both of them have same denominator, cancel out. 32 divided by minus 2 is minus 16. So finally, our stationary point, the coordinates are x is natural log 4 over 3 and y coordinate came out to be minus 16. This is the point. Let's go to the B part. Use substitution, this u equal to e to the power x and partial fractions to find the exact value of fx from, okay, so I will do that here. If it is from natural log 3 to natural log 5 and our equation was e to the power 2 e to the power 2x, e to the power 2x minus 3x plus 2, okay. 2 e to the power 2x over e to the power 2x minus 3 e to the power x plus 2 dx. Okay, now they have asked us to substitute u equal to e to the power x. So u equal to e to the power x. That means du over dx equal to e to the power x again. So du equal to e to the power x dx, right? Okay. So what does it become? The integration part becomes 2 e to the power 2x. So we can write 2 e to the power 2x. So no, not 2x. I'll write e to the power x, e to the power x, and then dx. I broke this e to the power 2x into two parts so that one of them becomes du, e to the power x dx. Okay. Divided by no change in this case, so it can become e to the power x square. Yeah, e to the power 2x can be written like this: minus 3 e to the power x plus 2. All right. So the numerator becomes 2. This e to the power x will be u. This e to the power dx will become du, divided by u square minus 3u plus 2. And now we have to carry out partial fraction. Okay, this becomes our equation. Meanwhile, I should also change the limits. So since I have assumed this, let me change these limits also. So if u is e to the power x, and it becomes when u is natural log 3, when x is natural log 3, then what happens? U becomes e to the power natural log 3, right? So e and natural log cancel out, u is equal to 3. That means our lower limit becomes 3. Similarly, this will give us 5. So it becomes 3 to 5, our limits for u. Okay. Now I'll factorize u square minus 3u by splitting the middle term. So u square minus 3u plus 2. This has to be factored out. So u square minus 2u minus u plus 2. I splitted the middle term to factor this. So u is taken common. It becomes u minus 2. Take minus 1 here, u minus 2. So u minus 1, u minus 2. This is our denominator, new denominator here. So our integration becomes from 3 to 5 2u over u minus 1, u minus 2. Correct? Yeah, 2u du. Okay. Now the degree of numerator is less than degree of denominator. That means we can carry out partial fraction. So let 2u over u minus 1 u minus 2 equal to a u minus 1 plus b u minus 2. Okay. So to find a and b, we'll have to take their denominator also, as that's LCM, u minus 1 u minus 2. So this becomes a u minus 2 plus b u minus 1, which will be equal to 2u over u minus 1 u minus 2. Since their denominators are same, ignore them, cancel out. We'll just look at the numerators. For numerators, we'll assume first, to make this 0, I'll assume u equal to 2. So 2 times 2, 4 is equal to 2 minus 2 will be 0, so this is gone. B is the only one left, 2 minus 1. So B is 2 minus 1 is 1. B comes out to be 4. What about the other one? Let to cancel this u minus 1, I'll assume u equal to 1. So 2 times 1, 2 is equal to, a will remain a u minus, which is 1 minus 2, yeah, in place of 1. And this becomes, b becomes 0, we'll get a because of this. What will that be? So 2 is equal to minus a is equal to minus 2. So our integration, which we started here rather, is from 3 to 5, and this becomes a over u minus 1, a is minus 2. Minus 2 over u minus 1 du plus b is 4. 4 over u minus 2 du. Okay. And I'll continue that here. So the integration becomes minus 2 natural log u minus 1 plus 4 natural log u minus 2 plus c. Okay, so we had to integrate, we have integrated. Now from 3 to 5 we have to find it. Substitute 5 first. So minus 2 natural log 5 minus 1 will be 4 plus 4 natural log 5 minus 2, 3 minus, I'll substitute 3 now, minus 2 natural log 3 minus 1, 2 plus 4 natural log 3 minus 2, 1, and done. So natural log of 1 is 0, this is gone. This will be natural log of 4 to the power minus 2 multiplied by, because they are adding, right, 3 to the power 4. And because it's subtracting here, I can write plus, or let's write minus only, minus, here natural log 2 to the power minus 2 multiplied by, oh, so rather it is gone, that's it. Okay, so this is natural log subtracting. I can write natural log 4 to the power minus 2 times 3 to the power 4 minus 2 to the power minus 2. Okay, so this becomes, I'm doing everything manually. You can just put your calculator, this in your calculator, this part, and you'll get your answer, this one. Okay, so it will be 81, which is this, and when it becomes positive, when it goes up, so it becomes 4, 2 square 4, and 4 to the power 2 is 16, will be down. So 4. Did they ask for exact value of this? Give your answer in the form of natural log a, where a is a rational number in its simplest form, and natural log in simplest form. This one, we got 81 over 4. So natural log of 81 over 4, so this becomes our a. A is 81 over 4. This concludes our solution video. I hope you liked it. If you really did, please give it a thumbs up, share with your friends, and subscribe to Math United. Thank you very much for your attention.